Let's take a look at constructing a polynomial given certain information. In this problem, we have real roots, -1, 1, and 3, and we're also told that 2 and f of 2 is 2, 4. That means that when I put a 2 in for the x, I'm going to get a 4 out for the y. The function's value is 4 at that point. So let's review a little bit. First, if I have a 0 or a root, then I also have a factor. So c is the 0 or the root, then x minus that is the factor, and that works both ways, of course. So given that we have some real roots, that means we have some factors. X minus a minus 1 turns that into x plus 1, then x minus 1 and x minus 3. The one thing we have to make sure of is that we put an a out here in front because we're not sure what the leading coefficient is. In order to find that, we have to use this other piece of information that 2, 4 is on my function's graph. So using that means I'm going to plug in the 2 for the x. So I put in the 2 where all the x's were, and I set that equal to 4. So the only thing I don't know is the a. Simplifying, we come down and discover that a is -4/3. At that point, then, I'm able to determine my actual function. It would be -4/3, where my a was, and then my factors. I don't have to multiply it out. You can if you want, but you don't need to. As a way to double check myself, I'm going to put this in my calculator and graph it. And I want to make sure that all the numbers that I was told were zeros or roots actually do show up at as x-intercepts. So let's go ahead and look at another one, because another thing that can come in is that thing called multiplicity. So in this problem, we have real roots, -2 and 12, but we're told that the 12 has a multiplicity of 2. We're also given another point on the graph to help us find that a. So multiplicity is telling me how many times we are using that as a factor. It's the exponent. So in this problem, I'm going to have my a times my x plus 2, again, because it's x minus a minus 2, and then the x minus 12, but this one gets an exponent of 2. Graphically, that should mean that it touches and turns at that x-intercept rather than crossing. We'll verify that once we're finished. Okay, so I have my point here of -3, 5. I'm going to plug that in. Once again, I'm going to simplify and solve for the a. So in this one, I am discovering that a is a -1/45. So when I put that back in, my general equation would be -1/45 times that x plus 2 times that x minus 2 quantity squared. And I would want to go ahead and take my calculator and go ahead and go in here and clear this out. And let's put in this new one, -1/45. And then just parentheses the x plus 2, close that, parentheses x minus the 12, and we're going to make sure we square that. On this one, the window is going to need to be adjusted, because if I have a real 0 at 12, I need to go beyond that on my x-axis to see it, so I'm going to go ahead and go up to 15. Let's go ahead and take a look then at the graph. Okay, there we go. So we see that it is crossing here at -2. It looks like 12 here. If you want to verify, just hit trace and put in 12. And yes, it confirms that that's 0. The other thing we could do as a check for ourselves is make sure that -3, 5 is on there. So if I put in -3, it does confirm that my y value is 5. So constructing the polynomial given the factors, or given the roots rather, means you're just making it into a factor and then solving for your a. Let me know if you have any questions.